Hello guys, welcome back to CodeLens, where we venture into the uncharted waters in matter software. If you are new to the channel, feel at home and be sure to subscribe and turn on the notifications so you'll be notified when I post a new video. Now let's get straight to the objective of our today's episode, where we are going to now start the real-world application of developing the ticketing application. For this particular episode, we are going to have a look at how we are going to create the user service. As you remember, in our introductory section, we said that we are going to develop this ticketing application, which is going to be composed of about 4 microservices, which are the users microservice, tickets microservice, notifications, payments microservice, and ratings and reviews. So for this one, we are going to have a look at users microservice. Now, as you can see from my screen, we are going to follow a CQRS pattern to implement our users microservice. And as you can see, it's just going to be a series of issuing commands, which in return, the commands are going to be handled by a command or a query handler, which in return, depending on the action that you're going to perform, events are going to be generated, which eventually we are going to see how we are going to send the events on an event bus. All right, now to start us off, I would like to mention that I went ahead and created quite a number of commands and implemented them for the sake of time, and I'm just going to take you through the create user command, update user command, and get user or users query. And then at the end of it all, we are going to do now a hands-on practice where we're going to implement a delete user command. All right, but the general overview of this is that this is going to be the flow that we are going to see our users microservice behave. All right, now under project, I would like to show you the structure of the application. Right, now number one, we are going to see that we have aggregates. We also have a package code command, a package code controllers, entities, events, okay, exceptions, and logic, right? Also query and repository. Now, another thing I would like to mention here is that we are going to utilize Axon framework, which again is also an open source tool that which is going to help us actually develop a CQRS kind of an application. But there is more to Axon framework, but we are going to see as we progress along. All right, now the first thing that I also like to mention is that we are going to use PostgreSQL as our persistence choice. So if you remember from our environment setup episode, we did have this compose file, basically the infrastructure compose file, where we defined the dependencies that we are going to be using for this particular microservice series. All right, now without further much ado, I would like us to proceed to now the nitty-gritties. So to start us off, I'm going to run the application so that we can have a feel of what the application achieves so far. All right, so I'm just going to run this application. Give it a second as it wires up. One moment. All right, so awesome. So we are up and running. So I'm going to open Postman and show you the various actions that we have so far. All right, now I've already created an endpoint where we can be able to create a user, to get all the users, to get a specific user based on an ID, and to update a particular user. All right, so let us start and see what's going to happen here. So we can just come and say Michelle again. Let's leave the rest as a year. So I'm going to initiate a post. We're getting a 200. So let us come to our get users. All right, so if I now fetch, we are going to see that we have Michelle added in here. All right, now to get a specific user by ID, so I'm going to use the newly created user. Then I'm going to do a post. All right, we are able to get this particular user. So let us update this particular user and see what we are going to get. So I'm just going to copy this, then just edit a few items, at least just to make sure that we are getting the record being updated as required. All right, so this delete, we're going to implement it in our next couple of minutes. So okay, we're getting a 200. So if I get all the users, all right, so we can see that that particular record has been updated accordingly. And now if we have a look at our database, that is now PostgreSQL, as you can see, this is a record that we've just added and it is being persisted as expected. All right, now having seen how the overview application works, now let us now go and see how all that is being achieved. Now, as I mentioned, this is going to be just an issue of issuing commands and then generating events. Right, so the first thing that I would like to show you is in here, this is now the create user command, which is basically just a pojo for that matter, which contains the details that we want to persist. Right, so after having created a user command, we are going to see there is an aggregate that we are going to use. Now, if you're wondering what is an aggregate, here I've just put a simple definition of what an aggregate is, and basically you're going to see that an aggregate is just a business entity or group of business entities for that matter that is always kept in a consistent state, of course within a single ACID transaction. We are going to say that the aggregate root is a business entity within the aggregate that is responsible for maintaining this consistent state. All right, too much work or a lot of things going on there. So let us just have a look at a different kind of a scenario. So take an instance of, let's say, an ordering service. All right, so our aggregate in this particular case could be now the ordering functionality. All right, in the broader perspective. All right, in here now our aggregate root becomes now, for example, the orders business entity. All right, I hope this makes sense. If you think the clarification that you'd like them to be addressed, just shoot them in the comment section and they'll definitely respond accordingly. Now, having said that, now let us proceed with one instance of the create user command. In here, our now aggregate is user aggregate, so that is why I created this aggregate. All right, and since we are using Axon framework, make sure that you also annotate your aggregate with this aggregate annotation. All right, then from there we have an aggregate identifier. All right, so in here, what basically this aggregate and aggregate identifier means is that an aggregate is basically an annotation that informs Axon's autoconfigurer for Spring that a class is an aggregate instance. That's just it. As for the aggregate identifier, it identifies a field as identifier of that particular aggregate. All right, now having said that, we also have a command handler, in this case for a create user. All right, now the entry point is going to be here in our controllers. We are going to see that we have this endpoint which is called create, and we are sending a create user command. All right, now with this command we need to send this command to, so that it can be handled by our command handler. Right, now to achieve that, that is why we did create this command gateway, which is also Axon specific. All right, now with this command gateway, we come in here and set the command to be sent using the command gateway. All right, now in the aggregate, you are going to see that there is an command handler for the create user command, which is basically this is what is basically happening. And as you can see, within a command, this is where now we actually perform any business logic that we do. All right. So from there, we then publish. Basically we just create a user created event. All right. So once we've created a user created event, is going to be handled in the event sourcing handler for this particular aggregate, whereby we are going to see that we are basically just setting or basically modifying the state of our aggregate. All right. Remember, the event sourcing handler, again, this is also Axon specific. And what event sourcing handler does, it defines the annotated method as a handler for events generated by that aggregate. Bear that in mind. It defines the annotated method as a handler for events generated by that aggregate. All right. Now, having said that, let me show you now where the logic happens. Now, once we have created a user, we publish a user created event. All right. And that user created event, I did handle that on a different component, which in my case, I defined it as user projection. All right. And as you can see, this is just it. In here, we have our normal repository. All right. And then once we receive a user created event, mark you that we have also annotated this with an event handler. All right. So once we've received this event, we basically get the user ID and perform the normal CRUD operation of inserting, or basically saving the user to our database. So that is just what happens for all the other scenarios for create and update. So let us have a look at how we can be able to implement our delete user command. All right. So the first thing that I'm going to do, at least so that we can get an understanding of what is going on, I'm going to create another command, which I'm going to call delete user command. All right. And as is the norm, I'm going to put in here some properties which we are going to use. So this is going to be user ID. Now remember, as we have seen from all the other commands, for example, let me even use update user command, we must specify our target aggregate identifier. All right. So this is basically a target aggregate identifier. This is just an ID that is going to help us identify on which aggregate we are working on. All right. So with this, let me come back to our delete user command. In here, I'm going to annotate this as a target aggregate identifier. I'm going to use Lombok, at least so that we can have our getters and setters. And then I'm going to generate a constructor which is going to take a delete user command. All right. Now, having done that, I'm also going to create another project which I'm going to call delete, or basically user deleted event. All right. That's because it's a thing of the past. Okay, we've deleted a user, so I'm going to come and create user deleted event. Okay, with that, what I'm going to put in here is just going to be private UUID. Then I'm just going to say user ID. All right. Then I can just even set, let's say, private boolean. Say boolean. Let's say is deleted. And as usual, I'm going to annotate this with @data so that we can get again our getters and setters. And then I'm going to create a constructor which is going to take in those two parameters. All right. Now, having created that, the next thing now I'm going to create is to modify our aggregate so that we can be able to handle our delete user command and also to handle our user deleted event. All right. So let us come to our aggregate, which in this case is a user aggregate. Down here, I'm going to create a command handler. All right. So this is the first thing that you do, the command handler. Then I'm going to say public void, say on, in this case, that is if we receive a delete user command. All right, so this is just going to be a delete user command. Okay, so do your business logic here, whichever that you'd like to do. Okay, so do your business logic. Okay, now assuming you have done that, I'm now going to set this user ID. Remember, is our aggregate identifier. So since we are changing its state, we are going to say now our new user ID is still going to be the same one, but we're going to set is deleted to be is going to be use is going to be actually from here. Once we've done that, then we just need here to publish the event. So aggregate life cycle, I'm going to apply a new, this should be, we created that is user deleted event, all right, which is going to take the user ID, of course, which is that user ID, and then is deleted true. All right, awesome. So far we have handled our command, which just is going to generate, or basically to publish a user deleted event. Now within the aggregate, we need to handle the event sourcing handler for the user deleted event. So again, I'm just going to come and create event sourcing handler. Then I'm going to say public void on, this is user deleted event. All right, user deleted event. Once we've done that, again we set the aggregate identifier to user deleted event dot get the user ID, and then of course we can say is deleted is going to be the user deleted event dot get is deleted. That's pretty much it as far as our aggregate is concerned. But the next thing that we need to do in here is we need now to handle the event handler for our projection. All right, so I'm going to come here under logic and say we now need to handle the user deleted event. Right, so what I'm just going to come here and do is I'm now going to come and create now an event handler within the projection. So an event handler, then I'm going to say public void on user deleted event. Then I'm just going to put it like that. And the reason as to why I did split this logic from our user aggregate is at least number one, to make our code cleaner, right, and also to separate these two concerns from an aggregate to our projection. Right, now the next thing that we can do here is that we can just come and say user repository. Then I'm just going to find by ID, which should be user deleted get user ID. Then we can say if it is present, we now delete it. So I'm just going to say user entity. All right, so user entity, since in our case we'll just be doing soft deletion. All right, so user entity, we can say dot set is deleted. We can say user deleted event dot get is deleted. All right, and then from there we can now make our persistence, then save user entity. That's pretty much it. So now the whole flow is handled. All right, so for some reason our code is screaming the usual semicolon. All right, now with that we're pretty much done. So the other thing that we need now to do is to add our new endpoint, which should be able now to handle our delete user command. Right, now for that, what I'm going to create is another endpoint. Let me just create it in here. Just going to say delete. Then I'm just going to say I'm going to delete the user ID. Sorry, so just going to say public for now void say delete user. All right, so I'm going to put here the path variable. Okay, remember this is just the normal way of now creating the normal REST API. So you could even return a response entity of an object, but to make things simple, I'm just going to return void for now. So what we need to do here is now issue the delete user command. This is going to be the command is equals to new delete user command. Then I'm going to say a UUID from string, then I pass in the user ID. All right, from there I'm then going to use our command gateway to issue the command asynchronously. All right, as you can see, I'm going to use the send. If you want to wait for the result, you can just do a send and a wait, which is now going to give you an object response, right? So but in my case, I want it to be asynchronous, so I'm going to do send, then the command. Okay, with that we are pretty much done. Now we can test and see how, or basically if our logic works as expected. So I'm going to now rerun our application. Give it a moment as it wires up. So as you have seen, this is not something complicated per se. It is something which is very much doable, right? So let it wire up. Awesome. All right, so our application is up and running. Let us now initiate a request and do our soft deletion implementation. So let us get all the users first. Let us take a user who has not been deleted. We can use this ID. So we expect when we send a deletion request, we should see this value change to true. All right, so I'm going to come in here. I'm going to place this ID and then I'm going to send. So let us get the users again. Let's see what happens. So this is our ID, and now as you can see, is deleted value is now true, which is definitely the same thing that is going to be replicated on our database side. So we have seen how we can be able to create a command, how we can be able to generate an event, and also how we can be able to handle those commands, and also how we can handle the events which are generated. Now in the next episode, we are going to see how we can be able now to publish these events on an event bus. In this case, we are going to send these events to a RabbitMQ, and that from there we can be able now to have other services subscribe to those events and act accordingly. Before we call it an end for this episode, we saw that we are able to get all these users. We are also able to get a user by a specific ID. So how does this all work? Now let us come back to our users controller. Let me show you how it works. So the first thing that we need to do, of course, is create the endpoint that is going to enable us to get a user, let's say by an ID, which is this one. All right, and as you can see, we are using another feature which Axon gives us, which is called the query gateway. All right, as we have seen with the commands, we use a command gateway. For query, we use a query gateway to issue query requests, which in turn are going to be handled by Axon framework internally. So let us have a look at how all this works. So in here, when I get a request, then I specify the user ID. I'm just coming and saying query gateway, then query find user query. Now let us have a look at what this does. So if you see, this again is just another POJO, right? So it's just a POJO representation of our user ID query, which we are going to see that is going to be handled in our projection side. So as you can see, this is now the query handler. We did issue a find user query request, which internally, as you can see, just by marking it as a query handler, basically that is marking this method as a query handler, and then specifying the query that has been issued, we then just do a user repository, then we find by ID, then the find user query dot the supplied user ID. That is just it. So the query handlers are pretty much easy. All right. Now, as for the use case of getting all the users, the only difference here is that instead of just sending response type dot instance of the entity class, we now tell Axon that we need multiple instances of this particular class. So in this case, we are saying response types dot multiple instances of the entity class dot class. That's just it. Again, if we see what is happening in here, this is just should I say like a marker class, all right, which internally again is going to be handled in our projection class, where we just return all the users. All right, so maybe in here you may want to filter and not return maybe the deleted users. All right, so this brings us to an end to this particular episode of developing the user service. I hope to see you on the next episode as we continue to build upon our ticketing application. As we go deeper and deeper into the series, we are going to see quite some amazing concepts and ideas which we can use when it comes to developing an application from a microservices point of view. Once again, in case there are any questions or concerns, shoot them in the comment section and I will gladly respond accordingly. See you on the next one. Goodbye.